Hypotheses and objective. Concerned with above perspective, we address the question of tsunami's impact on sea surface salinity, SSS, pattern changes pro and post-tsunami event of 2004. This is demonstrated with moderate resolution imaging spectrometer, MODIS, i.e. the aqua/MODIS data level IB reflectance satellite data using least square algorithm. 3 hypotheses are examined. Least square algorithm can be used to retrieve sea surface salinity in MODIS satellite data during and post-tsunami disaster. Least square algorithm is automatic algorithm for retrieving SSS for short periods, i.e. couple of days. There is changes in SSS pattern post-tsunami 2004 event along Banda Aceh coastline. Study area. The study area is located along the western coastal zone of Aceh with boundaries of latitudes 3 degrees 30 N to 6 degrees 30 N and longitudes of 93 degrees 30 E to 99 degrees 30. The Sunda Trench is running north-south along the coastal waters of Aceh towards the Andaman Sea. Running in a rough north-south line on the seabed of the Andaman Sea is the boundary between 2 tectonic plates, the Burma Plate and the Sunda Plate. These plates, or microplates, are believed to have formerly been part of the larger Eurasian Plate, but were formed when transform fault activity intensified as the Indian Plate began its substantive collision with the Eurasian continent. As a result, a back-arc basin center was created, which began to form the marginal basin which would become the Andaman Sea, the current stages of which commenced approximately 3 to 4 million years ago. On December 26, 2004, a large portion of the boundary between the Burma Plate and the Indo-Australian Plate slipped, causing the 2004 Indian Ocean earthquake. This megathrust earthquake had a magnitude of 9.3. Between 1300 and 1600 kilometers of the boundary underwent thrust faulting and shifted by about 20 meters, with the seafloor being uplifted several meters. This rise in the seafloor generated a massive tsunami with an estimated height of 28 meters, 30 feet. Location of study area. Location of Sunda Trench. The average depth of the sea is about 1,000 meters, 3,300 feet. The northern and eastern parts are shallower than 180 meters, 600 feet, due to the silt deposited by the Irrawaddy River. This major river flows into the sea from the north through Burma. The western and central areas are 900 to 3,000 meters deep, 3,000 to 10,000 feet. Less than 5% of the sea is deeper than 3,000 meters, 10,000 feet, and in a system of submarine valleys east of the Andaman-Nicobar Ridge, the depth exceeds 4,000 meters, 13,200 feet. The sea floor is covered with pebbles, gravel and sand. Further, the climate and water salinity of the Andaman Sea and Aceh are mostly determined by the monsoons of Southeast Asia. Air temperature is stable over the year at 26 degrees Celsius in February and 27 degrees Celsius in August. Precipitation is as high as 3,000 mm/year and mostly occurs in summer. Sea currents are southeasterly and easterly in winter and southwesterly and westerly in summer. The average surface water temperature is 26 to 28 degrees Celsius in February and 29 degrees Celsius in May. The water temperature is constant at 4.8 degrees Celsius at the depths of 1,600 meters and below. Salinity is 31.5 to 32.5 parts per thousand, in summer and 30.0 to 33.0 in winter in the southern part. In the northern part, it decreases to 20 to 25 due to the inflow of fresh water from the Irrawaddy River. Tides are semidiurnal, i.e. rising twice a day, with the amplitude of up to 7.2 meters.